Tell me if this sounds familiar to you. You've just finished building your CNC machine and you're ready to start making some chips, but you still haven't trammed the thing, so you can't. So you hop on Google, you hop on YouTube, you try and find any information that you can on how to tram it, and there's not very much out there, especially for hobby machines. But luckily for you guys, I've just finished converting my V2 over to lead screws, so I need to get the thing trammed. That's a perfect excuse to bring you guys along with me. Let's get to it. So what does tramming even mean? It's actually pretty simple. Tramming just means making sure the plane that your X and Y axis moves in is perpendicular to the plane your Z axis moves in. Notice how I said planes of movement, not just directions like left, right, up or down. That little detail becomes super important when we start talking about tramming the column of your machine later. But before we get too ahead of ourselves, let's talk about tools, because everybody loves tools. First thing you're going to need is a dial indicator. You can use a DTI, but a standard dial indicator is going to make your life a little bit easier here. You'll also need some way to attach that indicator to the machine, and it's important how you do this. The correct way to mount your indicator is to attach it at the spindle, but don't just shove it straight into the spindle collet. You want it mounted on an arm that spins concentrically with the spindle center. If you don't have an arm, all you'll be measuring is the flatness of the work area and not how tram it is. If we hop into Fusion, you can see this better. Notice how, even if I exaggerate the tram error, the end mill never gets further away or closer to the bed, and that's because the plane of travel isn't changing in reference to the plane of the end mill. Now you might have seen those fancy SST tramming tools online, and they're cool, but honestly, you don't need one. The one I use is just 3D printed with a couple of heat inserts to clamp everything down. The arm's length doesn't matter too much here, so long as it's not too long for your machine, and on one end, I have a pin that fits into the collet, and on the other is where I mount the indicator. As long as the arm's rigid enough to hold the indicator without flexing, you're good to go. Next up, you'll need something flat to tram against. Most DIY CNC machines, especially ones using aluminium extrusions, don't have super flat beds to start with. But luckily, you've got options. I personally use a set of parallels because they're ground in pairs, so they're guaranteed to be super flat and parallel relative to each other. You can also use a set of 1, 2, 3 blocks in the same way, since they're often ground to within a decent tolerance, but just understand they won't be as accurate as parallels. You can also use the top surface of your fixture plate, if you trust it enough to be flat, that is. And finally, if you're really cheap and don't want to buy any of that stuff, that's no big deal. You can just use a piece of glass from an old picture frame. Just make sure it's actual glass, not plastic or polycarbonate, because that won't work. And lastly, you're going to need shims. You can buy pre-made shim stock online if you want to be fancy, or you can just cut up an old soda can. A little tinfoil works too. Whatever you've got, it doesn't have to be fancy or complicated. So long as it's thin and made of metal, it'll work. When we talk about tramming, we don't refer to tramming a specific axis. Instead, we talk about tramming in reference to an axis. And I know that sounds confusing, but stay with me. For example, in Fusion, if we tilt this assembly left and right, you're affecting the tram along the x-axis, but we don't call this tramming the x-axis. Instead, we call this tramming about the y-axis, since the change is happening in reference to the center of rotation of the y-axis. Generally, on a 3-axis vertical machine like Milo, you don't get the luxury of tramming the table itself. Almost all of the tramming work happens right at or really close to the spindle. Now, for tramming about the y-axis, that's not really an issue. But when it comes to tramming about the x-axis, if you're not careful, it's really easy to lull yourself into a false sense of security. Remember way back at the beginning when I said there was a reason I was using the phrases planes of motion instead of just saying directions? Well, this is why. So on Milo, there are basically 3 ways you could tram about the x-axis. You can shim the Z column itself, you can shim behind the Z plates, or you can shim underneath the fixture plate. And technically, any of those options will get your dial indicator to show good numbers. but only one of them is actually correct in terms of maintaining your true planes of motion.
You want to experience
True planes of motion.
Do you? Yes?
Now the second two, those are definitely the easiest, because you don't have to unbolt or wrestle with a heavy ass column every single time you want to check the tram. And if you take a reading with your indicator, it'll probably even tell you that you're perfectly trammed in. But here's the catch. If I move the Z-axis downwards along the Z rails, the spindle mount actually starts moving a little in the Y direction as well as the Z. And that right there will tell you everything that you need to know. Even though the indicator says you're trammed, the movement isn't perpendicular. The axes are aligned, but the planes of motion are not. So what do you actually do then? The best approach, and the one that I use, is to tram the column first. Get it as close to perfect as you can. I usually go until the Z column is within about 0.1mm of tram about the X, and once that's dialed in, then I'll fine tune by shimming the Z plates or the fixture plate. That last bit of tweaking brings the tram of the X axis to under 0.05mm, which is more than accurate enough for the kind of work I do. Is this a bit of a compromise? Yeah, but that's the game. This machine will only ever be as accurate as the patience you have to tune it. Now that we've covered the theory, let's actually tram something. The first step is to get a baseline. I like to start with what I call a dirty tram. Just grab a couple 1, 2, 3 blocks, place them underneath the spindle, and lower the Z-axis until it just touches the top of the blocks. Then, loosen the 4 bolts holding the spindle. On V2, there's an additional Z plate for Y-axis tramming. I'll loosen that too. If your machine only has a single Z plate, just stick to the 4 spindle bolts, nothing else. With the spindle lightly pressing on the blocks, you can start tightening things back up. But here's the trick. Tightening bolts too vigorously can pull your tram out without you noticing, so go slow. Snug each bolt gently to hold everything in place first, just enough to stop it from shifting. Once everything's sitting where it should, then tighten everything fully. And now it's finally time to use your indicator. Tramming uses what's called a comparative measurement, which just means you zero the indicator in one spot, spin it 180 degrees, and then check for the difference. If the reading stays the same, your spindle is square and trammed. If it changes, then you're out of tram. You're going to need to make sure that you're taking your readings in the correct spots. To tram about the X-axis, measure at Y min and Y max, or the front and the back of your work table. To tram about your Y-axis, measure at X min and X max, or left and right on your table. That way, you're comparing across the correct direction for the axis that you're adjusting. Now, if you're using something like Milo and your indicator arm is too big to fit under the mill's shoulder, don't stress. You can offset your readings. Just rotate the indicator arm as far back along the Y-axis as it'll go on one side of the column. Then, picture a straight line from that position running parallel to the Y-axis. Where that line hits the arc of the indicator sweep near the front, that's your second measurement point. It's not perfect, but it's still accurate. Do the same thing on the other side of the column to double check and rule out any twist. Like I mentioned earlier, because of the style of machine that I'm using, I'm starting with tramming about the X-axis, which means I'll be shimming underneath the column. How much you shim depends on how far off of tram you are. There's probably a mathematical way to calculate the exact shim thickness, but honestly, trial and error works just fine, and it's usually faster. Same rule applies here as before. The torque you apply when tightening the bolts can shift your tram, so always take your readings with the bolts fully tightened. Yeah, it's a pain having to loosen and tighten the column over and over again, but if you want accurate results, there's no real shortcut. It just takes a bit of patience. If your machine doesn't have an independent way to tram about your Y-axis, like on Milo V1.5 for example, then you'll need to shim the column to adjust about the Y-axis at the same time as you tram about the X. It's a bit more work, but it's the only way to get both axes lined up properly when you don't have a separate adjustment point. If you do have a separate adjustment for the Y-axis, then you can follow the next bit. On the V2, there's a printed part that mounts on the back of the two tramming plates. It uses M5 screws to apply pressure to the side of the front plate. As you screw it in, it pushes the plate sideways, shifting it in or out of tram. It's a simple setup, but it makes fine adjustments way easier than trying to tap things into place by hand. It's a good idea to have two of these little tramming assistants, one on each side of the plate, so that they apply force evenly from both directions. That way, when you go to tighten everything back up, the plate's held in position and is less likely to shift out of tram when you torque things down. Once you've performed your initial tram, it's a good idea to double check your measurements just to make sure everything's good. If it isn't, just keep repeating the process until it is. If you're using a spoil board on your machine, it's a good idea to face it down at this point. That way, you're evening out any errors that you might have due to the surface not being flat. And that's it. That's all it takes to tram. I hope this has helped some of you, and have a great day. Bye now.